Okay, so first question, can you see my screen?
Yep, seems good.
And the second question, can you hear me, is also answered now. Perfect. So, okay. And then, okay, so here we go. Okay, so, ladies and gentlemen, Darwinism, so the theory from Charles Darwin that not the strongest survive, rather they who can adapt faster. And in fact, currently in the banking industry, only the banks survive who adapt their services faster than their competitors and bring these services to the digital banking market. But the question is, what is necessary to do that? And here we need three things. We need the cloud, we need microservices, and we need a mobile banking app. And of course, the right test automation strategy. So, hello, ladies and gentlemen. My name is Rudolf, and during the next, I guess, 20 to 25 minutes, I will talk about the test automation journey of a conservative bank that entered the world of digital banking with microservices, the Amazon cloud, and the mobile banking app. So, first, who am I? My name is Rudolf. I'm an HR engineering coach at the Raiffeisen Bank International, short RBI. I'm also the guild lead for our test and test automation guild, where we have around 180 members from all of our network banks. And as an HR engineering coach, together with my colleagues from the HR engineering support department, we are helping the RBI product teams in the area of test automation, CI, CD, DevOps, and so on. Since around 7 years, we have an agile transformation, and in the meanwhile, we have around 750 agile product teams. And in addition to my work as agile engineering coach, I'm also the organizer of the Agile Test Automation Meetup Vienna, and I'm hosting 8 times per year the Testbusters Nights Vienna. At the end, I will give you more insights. And last but not least, I'm writing articles for magazines about test and test automation. If you want to contact me, then here you can see my email, and you also find me on LinkedIn. So, a short overview, short introduction into Raiffeisen Bank International. This now I'm do not telling you, so we are the best bank and so on. Only that you have an understanding. So, what is this all about? RBI operates a banking network in Central and Eastern Europe, and we cover around 13 markets, and we serve more than 16 million customers with roughly 3,000 branch offices. And the RBI headquarters is in Vienna. So let's start with an introduction of the RBI Group Digital Solution Program. Years ago, RBI started with the Group Digital Solution, a program in order not to miss the digitalization of the banking industry. Due to all the new kids on the banking block, better known as fintechs like Inkdiba, N26, Monzo, and Co., who now offered all the banking services via the internet, it was necessary that we, as a traditional conservative bank, do the same. Imagine what does it mean for your business if your competitor makes it possible to open a bank account on a Sunday within 15 minutes via the internet. This is a nightmare. We need 2 hours, and you must come to us in the branch. Yeah, so shades of Charles Darwin. And our answer to handle this nightmare, to tackle this nightmare, was the Group Digital Solution Program, short GDS. And the goal of the Group Digital Solution was to offer a new banking platform in the cloud called Merlin, an open banking API platform called Galileo, and a new banking channel via a native mobile app called My Raiffeisen. My Raiffeisen, the mobile banking app, covered in phase one only the Hungarian and the Romanian market. And with group digital solution, new technologies and approaches such as the Amazon cloud, microservices, REST APIs, DevOps, continuous testing, and so on came into the bank. And therefore, the topic of software testing, whether it is manual or automated, had to be redesigned and implemented from scratch. So let's take a look at the challenges of microservices. Until GDS, we in RBI had only big, fat, monolithic applications. The rollout cycle was 2 to 4 times per year. With GDS, we got a lot of microservices running in Docker containers in the Amazon cloud, which can be accessed via REST interfaces from inside the company and from outside the company with every web browser and every mobile device. And microservices have the industry buzzing. Why? Think about faster release cycles. Think about the ability to take services on and offline without affecting the entire application, as you have seen it before in the talk. Think about the agility to keep up with customer demands. And the test strategy for microservice for a microservice architecture must cover different topics like Docker containers, Amazon Web Services, REST APIs, API gateways, mobile apps, mobile devices, and so on. In this talk, we only take a look at the functional tests of microservices. Originally, this talk also covered the mobile device testing approach, but due to that, I only got 25 minutes for this presentation. We only take a look at the microservices. Yes, and details about performance testing, security testing, and so on, yeah, are out of scope. We only talk about functional testing. But due to the fact that I have seen how other companies are doing performance testing, I'm really jealous. So here you can see the simplified group digital solution architecture. We have the front-end layer for web and mobile. Then we have the API layer. Then the third one is the Merlin layer, where all our microservices and components are running in Docker containers in the Amazon cloud. And then we have the backend layer with an API gateway to access the network banks in Romania and Hungary. And you can imagine that a microservice architecture is more complex than monoliths, or let's say it is complex in another way. And there are three key differences that affect your testing strategy when you're dealing with microservices. So first, it is interconnectivity. A microservice application can have hundreds of individual microservices spread across different machines. And these services must communicate across the network in different ways. And testing these communication, the error handling, the resilience, and so on, yeah, is a challenge. The second thing is independency. So each microservice needs to be independent. So it delivers a single functionality and can be developed in a different technology. And independency means that each service could be replaced, managed, or deployed without affecting the entire system. And then, third, it is about scalability. Microservice abilities like concurrency, performance, and recovery are usually handled by scaling the microservice, mean running more instances of a microservice in parallel. And here we must consider concurrency testing to check how the system will hold up if all the services are used at the same time. Scalability is a powerful advantage of microservices and must be considered in your testing strategy. So let's have a small quiz. Which object has to be shown on at least one slide at each test event? Yes, you're right. The test pyramid. The test pyramid should not be missed at any test conference or test meetup. But keep in mind that the pyramid is only a model, and the original pyramid was a great model for testing monolithic applications. 3 layers are enough. And this is our test pyramid, when microservices came into the game. Now we have 5 layers. And for the effective test approach of microservices, we should always bear in mind that the overall system and isolated microservices works as expected. Let's start with the unit layer. At this level, we verify that the core functions work correctly in isolation from external references. Here we are checking that we have built the system right. We test the methods and the classes of a microservice. And now we are at the service layer. And testing at the service layer dives deep into all the functions within the microservice in isolation with mocked dependencies. In addition to functional tests, we already tested here some non-functional things like performance, a little bit performance, and security too. And then next we have the service integration tests. So the service integration layer. With these tests, we verify that our microservices works in conjunction with other components, with databases, with messaging systems, and other microservices. And these tests are tricky since you have many independent services that communicating with other independent services in many ways, in a synchronous way, in an asynchronous way, And service integration testing verifies that a set of microservices delivers a feature. And how we at RBI have organized this. So we are collecting, we collected microservices to a so-called, to a bounded context. We call it a cabinet, and verified that the cabinets collaborate as designed. Here we test the main path, the happy path, the negative path, and some of our edge cases. So what happens if a service dies? What happens if a bit of a component dies? For instance, a Docker container. Things like this, things like that, we test at this layer. So, and then let's have a look at the special type of integration test, which had been forgotten for a long time and only come back on the stage through microservices. Let's talk about consumer-driven contracts. So, at the API layer, we test that the API works correct with the microservices. Especially when services, microservices, and the APIs are developed by different teams, the risk for misunderstanding, unexpected behavior is high. Where the API and microservices was was developed by the same team, our standard API test was sufficient. Where the API and the microservices were developed by different teams, we had a lot of issues since the country teams, so Romania and Hungary, sometimes provided the data not as specified or changed the interface without information. And therefore, we decided to use consumer-driven contracts to test the Merlin connector. The Merlin connector is our API gateway to the microservices of the countries and their backend services. And consumer-driven contract testing is a technique where the consumer, in our case Austria, defines the contract in form of a test. The verification, the test, is then executed against this contract at the provider side in their software development lifecycle, in our case, in Hungary and Romania. And for implementing consumer-driven contracts, you have to use special test automation frameworks. More about our frameworks you will see later. So we are using contract tests to ensure that the interfaces between the provider and the consumer are implemented correctly. And contract testing is good to foster conversations. Contract testing can often make me, in our case the countries, recognize I'm going to break a bunch of services or APIs from other teams. So, and then finally, at the top of the pyramid, we find ourselves with the end-to-end tests, where a test scenario maps to a customer journey. A test scenario verifies that the system as a whole meets the business goals. And that's why, as much as possible, we try to keep the test boundary as the fully deployed system and accessing it through our UIs, in our case, web browsers and web browser, mobile browsers, and mobile apps. And our biggest challenge here was the provisioning of the physical mobile devices, since we needed more than 50 different devices to cover all of the different used devices in these two different markets. So let's take a closer look at the test automation. This is a picture of our delivery pipeline, where you can see 5 test stages. We have development, we have the system test stage, the system integration test stage, the user acceptance test stage, and production. And the goal of the teams was to deliver a change in the software within 15 minutes from development to production. And this speed, of course, was only possible with automating almost everything. And this last slide is now about our use test automation tools. And we have to distinguish between application code and infrastructure code. We tested, in addition to the application code, also the infrastructure. So at the unit test, we use the Spring Test Context Framework, since we developed our services in Spring Boot. Then on the service layer, we used Postman and Rest Assured for functional tests. For Gatling, for performance tests, we used Gatling, and for security tests, we used OWASP. For the infrastructure tests, for testing the infrastructure, we used Inspec and Molecule. Oops, so sorry, wrong direction. On the service integration layer, we used again Postman and Rest Assured, and on the infrastructure, also Inspec and Molecule. No, again, wrong. So, And then on the API layer, when we talk about the consumer-driven contracts, we used Postman, we used Rest Assured, and we used GetLink. And for testing the consumer-driven contracts, we used Backed. And on the end-to-end layer, again, we use Postman and GetLink. And for testing via the mobile devices, via the mobile app, we use the Appium. So we learned a lot in our group digital solution program in testing and microservice architecture, because this was the first time that we are developing microservices. This was the first time that we worked with the cloud. And I show you our top 5 lessons learned. So first, use microservices only if you really need microservices. Microservices are great, but you must deal with a lot of other things which are hard to learn and to do. Going the microservice way only because it is hip is the wrong approach. Number 2, use non-functional tests also at microservice level. Start with testing of non-functional features, of course, if it makes sense, already at microservice level. Execute base checks for performance and security at microservice level, and then go to the top of the test pyramid. Yeah, and then consumer-driven contracts. If your microservices and APIs are developed by different teams, then it is a must that you use microservices. If the microservices and the APIs are developed by the same team, yeah, I can tell you, then it is an overkill. So, and then lessons learned number 4, and this is now from the perspective of the mobile testing stuff. Yeah? So, if you do not need mobile device features like NFC for your app, then physical mobile devices are not necessary to test your app. In this case, you can use emulators or simulators whenever you want to check for compatibility and interoperability, and if you have functional tests. If you need more than 10 emulators, then a mobile cloud device lab uh, which provides you all these emulators would be the right choice. And then last but not least, use infrastructure testing. I can tell you that we faced a lot of defects where at the end, after a long time of debugging and so on, we recognized that the infrastructure was the reason. And due to that, we introduced infrastructure testing also for our components, for our cloud environments, for our Docker containers, and other components. So I'm at the end of my presentation. Again, here you can see my contact address, and also a short spoiler advertising of our meetup group. So if you want to join us in 2 days, we have the next Testbusters night. Here you see the URL to the event. I will also paste it in the chat, and it would be great to see many of you. And ladies and gentlemen, I'm at the end of my presentation, and now I'm ready for answering questions.